Hello students, today we will see principle of least action. So first of all, we will see what is the action of the system. So action of the system is the time integral of twice of kinetic energy is known as action of the system. Mathematically, it can be expressed that action of the system integral from T1 to T2 twice of kinetic energy dt. Okay. Now we will replace this the value of twice of kinetic energy. We know that from Lagrangian mechanics L is equal to T minus V and H is equal to T plus V. From Hamiltonian function is just T plus V and Lagrangian function is T minus V. If we add both sides, then L plus H is equal to T plus T, that is twice T. Okay, so in place of twice T we can write L plus H. It means that sum of Lagrangian and Hamiltonian function is twice of the kinetic energy. Also, sum of Lagrangian and Hamiltonian function is summation over k pk into qk dot. Okay, from this equation. So in place of L plus H we can write summation over k pk into qk dot, since L plus H is summation over k pk into qk dot. Now if we take delta on both sides, if we take variation on both sides, then the action of the system will be 0. So variation in A, that is variation is integral from T1 to T2 summation over k product of pk and qk dot dt. So this is 0. So this expression is nothing but the principle of least action. So this is the principle of least action. Now we will prove this principle of least action, or we will derive this principle of least action. Okay, for that we have to consider action integral, and we know that we have already studied in initial portion of this unit what is action integral. Action integral is S is equal to integral from T1 to T2 L dt, means time integral of Lagrangian is nothing but the action integral. So suppose this is equation number 1, and we'll take delta on both sides now. Okay, after taking delta on both sides, delta S is equal to delta, okay, integral from T1 to T2 L dt. Okay, suppose this is equation number 2. Now we will define delta, but delta is delta plus delta t d by dt. So delta can be written as delta plus delta t d by dt. Suppose this is equation number 3. So we will put the value of this delta into equation number 2, since delta can be written as delta plus delta t d by dt. Okay, see, this is change in t, this is also change in t, so delta can be written in this way. So we will put this into this equation number 2. So we get delta S is equal to delta plus delta t d by dt integral from T1 to T2 L dt. Now we will solve this. Okay, so this term with this first term and this term is also with this, so we will solve this bracket. So delta with this integral with both this term, so we will get delta S is equal to delta over integral T1 to T2 L dt, and here delta t d by dt integral from T1 to T2 L dt. Okay, now we will bring this term inside the integral as well as this delta 2 inside the integral. Okay, so delta S is equal to T1 integral from T1 to T2 delta L dt. Here we will bring this term inside the integral, so delta t d by dt L dt. Now d by dt and d by dt with respect to d by dt is 1, so in the bracket the term will remain d delta t into dt. Okay, delta t into dl here. And we know that the Lagrangian is the function of qk and qk dot, since Lagrangian is depend on qk and qk dot, so Lagrangian is the function of qk and qk dot. So here we can write Lagrangian is the function of qk and qk dot. Okay, now we will apply the chain rule to this. Okay, we will solve this delta L by using chain rule. Okay, so we will apply the chain rule here. So after applying chain rule, we know that we will take first partial derivative with respect to qk into delta qk, then partial derivative with respect to qk dot into delta qk. Okay, with the sign of plus. So we will apply the chain rule here. So you will get del L by del qk into delta qk plus del L by del qk dot into delta qk dot. Okay, since there are the terms related to the k, okay, there are the terms involving k, so it it is applicable to the system of particles, hence we will put summation also here, summation over k. Okay, so this term, okay, came by chain rule. Okay, we have applied chain rule here, delta L, to those two parameters qk and qk dot. Okay, on second integral, we have kept second integral as it is. So suppose this is equation number 4. Now we will solve this. Okay, so we will find out those terms involved in the first term of equation number 4. Okay, so we will find del L by del qk, we will find del L by del qk dot, we will find delta qk dot. Okay, so from Lagrange's equation of motion from conservative system, according to the Lagrange's equation of motion, we know that d by dt del L by del qk dot minus del L by del qk equal to 0. This is the famous Lagrange's equation. Okay, we'll bring this to right hand side, so it will become plus. So d by dt del L by del qk dot is equal to del L by del qk, since del L by del qk is d by dt del L by del qk dot. Okay, again we can write this. Okay, a equal to b can be written as b equal to a. So here del L by del qk, del L by del qk is equal to d by dt del L by del qk dot. Now we know that del L by del qk dot is nothing but pk. Okay, we know that del L by del qk dot is pk. Suppose this is equation number 5 and del L by del qk dot is pk. So here is derivative of pk. Okay, can be written as pk dot. So since it is time derivative of pk, so it can be written as pk dot. So del L by del qk is equal to pk dot. So suppose this is equation number 6. So we got the values for del L by del qk dot, that is pk, and del L by del qk, that is pk dot. Now we will find out the value for delta qk dot. So delta qk dot can be written as delta qk dot can be written as dqk by dt, time derivative of qk. Okay, delta dqk by dt, we will bring this delta inside the differentiation. So d by dt delta qk, suppose this is equation number 7. So we got the values for del L by del qk dot, del L by del qk, and delta qk dot. So all of these values we will put in the equation number 4. Okay, so putting del L by del qk dot, del L by del qk, and delta qk from equation number 5, 6, 7 to equation number 4. Okay, therefore equation number 4 becomes, we have put all the values. Okay, we have put the value of del L by del qk, that is pk dot delta qk, and del L by del qk dot, that is pk. Okay, and d by delta qk dot, that is d by dt delta qk. So we have put all those values in equation number 4. So we got these terms. Okay, now we will solve this these terms. Now we just interchange these terms, pk dot and delta qk dot. Here we put delta qk dot, and here we put here a into b can be written as b into a. So here we write delta qk first and pk dot on second position. Okay, so that is, we have taken it intentionally, or we have taken this step intentionally, because we can say that if it is first function and this is second function, okay, this second function and then first function, so we can see the product rule of derivative here. Okay, so pk dot can be written as dpk by dt, pk dot can be written as time derivative of pk, dt of pk. Okay, now we can see that this is, if suppose this is first function delta qk and pk is second function, so we can see here first function d by dt, derivative of second function, plus second function d by dt of first function. Okay, so here first function is delta qk and second function is pk. So here is product rule of the derivative here. Okay, first function delta qk is derivative of second function, that is pk is second function, plus second function, that is derivative of first function. So here is the expansion of product rule. Okay, so this is the product of derivative, these two terms is the product of derivative of two functions, that is qk and delta qk and pk. So this can be written as the product of derivative of functions delta qk and pk. So this first term will be, this is the derivative of product of two functions. First function is delta qk and pk is the second function. So in previous step there is the expansion. Okay, there was expansion of that product of two functions, that is delta qk and pk. So this can be written as derivative of product of two functions delta qk and pk. Okay, here second term is as it is. Now we will find out delta qk into pk. Now we will find out delta qk into pk. So first of all we will consider delta qk. Okay, delta qk, and delta can be written as delta plus delta t d by dt. Okay, delta can be written as in this way, delta plus delta t d by dt. We have already seen earlier, into qk. Now this qk is operated over this term, so delta qk delta t d by dt into qk. So delta qk plus delta t d by dt qk, that is qk dot. Okay, dqk by dt is, that is qk dot. So we got delta qk is equal to delta qk plus delta t into qk dot. We'll bring this term to that side, so we'll get delta qk is equal to delta qk minus delta t into qk dot. So we got delta qk, but we have to find out the product of delta qk into pk. Okay, so we'll multiply pk on both sides. Multiplying pk on both sides, so we'll get delta qk into pk is equal to pk into delta qk minus pk into delta t into qk dot. Okay, so here again we have written here, we just rearrange pk and qk dot here, so pk into qk dot, and we kept the del t at the last. Okay, so suppose this is equation number 9. Now we got the value of delta qk and pk, okay, of equation number 8. So we'll put the value of delta qk into pk from equation number 9 to equation number 8. So after putting the value of delta qk into pk from equation number 8 in equation number 9 to equation number 8, so equation number 8 becomes, okay, delta s is equal to integral from t1 to t2 summation over k d by dt pk into delta qk minus pk qk dot delta t into dt plus, okay, integral from t1 to t2 delta t dl. Okay, now we will separate these terms, two terms. Okay, these two terms separate, we will separate. So this summation and integration is common to both terms, so we have separated these two terms. So integral from t1 to t2 summation over k, this is first term, minus integral from t1 to t2 summation over k d by dt, this is second term. Okay, now again I have quoted same step here, but look at here. Here is the integration and here is the d by dt differentiation. So we know that integration and differentiation is inverse processes, so they can be cancelled out. D by dt and integration can be cancelled out. Here also d by dt and integration, they are inverse processes, so they can be cancelled out. Okay, so only limit will remain. So limit over t1 to tt. Okay, say integration and derivative will be cancelled out. So here summation over k pk into delta qk, limit will remain, limits from t1 to t2, minus here also summation over k pk qk dot delta t, limits from t1 to t2, here also t1 to t2 delta t, okay, into dl. Okay, now this will be 0. Okay, this first term will be 0. We know that delta qk vanish at the endpoints according to the variational principle. Delta qk vanish at the endpoints t1 to t2. So since delta qk vanish at 8 points, this first term will be 0. Now we are left with these two terms, minus of this plus this term. Okay, now we will solve this integral. Okay, so to solve this second term, in this integral, second term on RHS right hand side. So we'll keep dl here and delta t here. We know that the integration of dl is L. Integration of dl is L. So it will be L into delta t. So integration of dl is L, and the limit is there from t1 to t2. Limit is there from t1 to t2. Now here is also limit is from t1 to t2. Here is also the limit from t1 to t2. So the common limits are there. So we can put inside that bracket. Okay. So bracket summation over k pk into qk minus L. Okay, here we have taken minus common. So summation over k pk into qk dot minus L, and delta t is common for both terms. So delta t is common, limits from t1 to t2. Okay, limits from t1 to t2. Now we know that this summation over k pk into qk dot minus L is h. Okay, since summation over pk into qk dot minus L is Hamiltonian function, that is Hamiltonian function h. Okay, pk into qk dot minus L summation over k is h. So here is h. Now, okay, So we have reached here, delta s is equal to minus h delta t, limits from t1 to t2. Now s is the action integral, and we know that the value of action integral is summation over integral from t1 to t2 l dt. Okay, so in place of s we can write integral from t1 to t2 l dt. This is action integral, this is the value of s. And here again we convert this term into integral, again this we convert this term into integral, because here left hand side we have added integral, we have put the value of action integral. So this right hand side we have also we have also have to convert it into the integral. So minus of, so this can be converted into integral from t1 to t2 h d of delta t, d of delta t. So we have converted this term into again integral. Now we will bring this term to that side. Okay, or we can bring delta to outside first. Okay, so we can take delta to the outside. Okay, after taking delta to the outside, so we are left with integral from t1 to t2 h dt. Now we will take this term to the right hand side, so it will be positive here. So delta, okay, delta over integral t1 to t2 l dt plus delta of integral from t1 to t2 h dt equal to 0. Here delta integral and dt is common. Okay, here delta integral and dt is common, so we will take the common. Okay, so after taking delta integral and dt common, we are left with inside the integral l plus h, and we know that l plus h is twice t, or l plus h is summation over k pk into qk dot. So this is nothing but this is the principle of least action. So this is the final expression for principle of least action. So we have proved that principle of least action. Okay, so today we have seen what is principle of least action and the complete derivation to prove the principle of least action. Thank you very much.